So thanks very much. So really what we're going to talk about how to develop high-performance applications. Now, some of you that may have been in Oracle for 20 years may realize that a lot of what we're going to say, we were saying 20 years ago. But let me clue you into what goes on in the real world. The mistakes that people made 20 years ago are still being made today on a daily basis. Because every year we graduate the next set of developers. Okay? They make the mistakes Graham and I made 20 years ago. Okay? It's happening every year. Education and coaching the next generation developers how to do it right is an ongoing process. They're not getting into school. You have to take the initiative and teach them and coach them. And we'll reinforce this. Extremely important. So the first thing we're going to do is what we did yesterday. We're going to do a little bit of a role-playing game, and we're going to have the same players. So Kaya's going to drive the keyboard. We have Robin and Graham as the real-world performance group. We have our DBA, who's sitting a little bit further away from me today. And we have our development manager, Tom, on the end. So shall we talk about this system? Now, this is a retail system, and we're a little bit concerned. We're concerned we're not going to make Thanksgiving. How many people in the room are concerned they're going to get through Thanksgiving okay and Black Friday? Rock on. Okay. Okay, so right. Okay, so we have this system that has basically missed every performance target we've ever set for it. Okay? This is our challenge. And this is what we're going to do. So, we're very disappointed with it. It's only achieving, about 300 or 400 transactions a second. And the response time, what is it, about 120 seconds, isn't it? 160 seconds. Milliseconds, right. So, it's way short of the target we were setting. We really are nervous about even letting this loose. The reality is that it has to go loose, and I've solicited the help of the Real World Performance Group. I have my DBA team, I have my development managers, and we're going to try and figure out how we're going to get through Thanksgiving. Now, like all these things, I've had a word from the board. They're looking for about 20,000 transactions a second, so when we're sitting at about 300 a second, we're way short of target. Okay? We're extremely short on target. So perhaps the DBA team would like to comment, because I hear on the back channel everyone's blaming the database. What does the DBA do?
Well, I'm looking at the database and I don't see too much wrong with it. We're using CPU, so
I know I tried this yesterday, but I'm pretty confident today that if we throw some more users at it, that will get better performance. So let's see if I do better today than yesterday.
So the suggestion from the DBA is there's nothing wrong with the database, connect more users. How many people have heard that in their lives? A few. And where did the DBA get that suggestion? Interesting.
Thin air.
Thin air, right. Okay. So we've added more users. We actually doubled the number of connections to the database, and I don't see any change to the throughput of the system. Does anyone in the room see a change in the throughput of the system?
Looks like there was a change in the response time. Yeah.
The response time numbers doubled, but that's the wrong way.
Thing, is it? Okay, so let's not double the number of connections to the database. I think we're a little stuck. Anything else you want to add from the DBA's point of view?
So I think you should ask the Real World Performance team.
Okay, Real World Performance team.
The first thing I'd like to make sure is, did we go back to the prior setting? Because have we gone back to the original setting? Good, because if we leave this increased every time your DBA says increase it, we're going to get a very high number by the end of this week.
Right.
So what we're seeing in the system right now is that we're dropping back to the original response time, but most of that response time is not part of the database time, so your DBA is correct about that. We're not spending much time in the database. That little, do we have the red line? Oh, can we see the red line?
Yeah, let's have a look at what
Let's have a look at
system
the
is.
breakdown for the system. Oh, okay. If we look at the system and the CPU usage on the database node, we'll see that the system CPU usage is about equal with the user CPU usage. So we're spending a lot of time, but we're not doing a whole lot of work because we're seeing a lot of activity in the active session window.
Yeah, so, I mean, the system, time spent in system is busy work in the operating system. It's not doing useful work for your application. It's not processing transactions for your application. We like to see maybe a 10 to 1 ratio between user and sys, right? And we're seeing 50-50. So that probably gives us an idea of where we might want to look next, because we're seeing a lot of time in system doing things at the operating system level. So now if we look at the low profile over on the right-hand side of the screen, the last line there is logons per second. Okay, so we're doing about 400 transactions per second. We're also doing about 400 logons per second.
That's interesting.
So, Dev Manager, what architecture have you implemented here? Because this looks like it's logging on for every transaction.
We're using the latest, greatest PHP build that you can get. And it's connecting pool inside of it. We're not spending any time in the application, and it's a database application, so it's got to be the database.
Right on. Okay. Anybody have conflict between development and performance engineers in your life? No change there. Perhaps the real world performance team would like to sort of make some suggestions or ask some more questions.
Yeah, so
Have you considered implementing a connection pool for this application?
We are using the default PHP connection pool, which very intelligently logs in and logs out each time so as to not leak resources.
Sure. Have we considered a different connection pool strategy?
No.
like to consider an alternative. I mean, if we look at the numbers, the response time that we're seeing is about 140, 150 milliseconds.
But why can't you tune this login, log out? It's a database thing. Make that go faster.
But your transactions, it's your application that's saying connect.
But you're taking too long.
So out of that 150 milliseconds, there's maybe less than 10 milliseconds is actually spent doing work.
Okay, so maybe we can do something like
Like a connection pool.
a different connection.
A different connection pool. Okay. Now we have a very fast development team here, so we get to implement these things in real time. Right? So if we can put in the connection pool.
So, this connection pool's got some merit to it, doesn't it? The transaction rate, as far as I see, we've jumped from the hundreds to the thousands. This real world performance team, they're making changes immediately. This is good. I like it. But the problem is I wanted 20,000. There seems to be a big brown thing there. So I'm going to talk to the DBA about it.
Why do I always get the brown thing? Okay, so let's see what's going on in the brown.
And if I read that correctly, does that say latch contention? That's true. Latch shared pool contention.
Shared pool latch contention.
Well, clearly we have to tune the shared pool latches. Right, so a little Google search here. And
Here's an interesting thing. What we should do, according to this Google search, is we should increase the spin count.
Is that the spin count you talking or the latch?
That's the spin count according to Google.
So, what value are you going to pick for this? I mean, it defaults to 2,000, right? It's been 2,000 for the last 15 years at least.
1 million.
Right, Oscar.
And if that doesn't work, maybe we'll just set it lower and see if that works.
Okay, so you propose pushing it up, and then if that doesn't work, dropping it down.
Yeah, isn't that the way we do tuning?
Sounds like you're guessing to me.
Perhaps.
Okay. Real World Performance Team. We've now got performance up to over nearly 3,000, but we're not at 20,000.
Well, these latches in the shared pool are all evidence of parsing problems. You're spending a fair amount of time parsing statements. And if we look at this lovely low profile we've got written over here, which shows us the kinds of values that we want to look at for these problems, we're going to notice that there is a large amount of hard parsing going on. Almost as many hard parsings as there are executions. The number is getting closer as we talk. How is it that you're building your application? Are we screen scraping to collect the values?
You know, we're just using the latest framework. SQL stuff, real simple SQL.
Dynamic SQL?
Well, all SQL is dynamic SQL. But if you're having a latching problem, isn't it a database thing?
So set spin count.
Yeah, you're thinking, do you have any ideas for what you should set spin count to?
I don't know what that is. That's a database thing. I send you SQL, you give me data, and that's our agreement, right?
We're getting it brown stuff.
Your agreement at present seems to be to do about 3,000 transactions per second, which I don't know what the boss thinks about that agreement.
We looked at other ways of doing it, but just taking all the stuff and concatenating it together with those little plus signs, it's real easy. So, statement.execute.
Well, Tom, have you ever heard of these things called bind variables? So a key way to avoid all these hard parsers that we're seeing in the system at present is, rather than using literals in SQL, this OLTP system, is to use bind variables. And then each time we come to execute the SQL statement, we just rebind a different value, it's not an extra parse, and the system's going to run much more efficiently. So, do you think there's any chance that we can implement some bind values in here?
I don't know. I've got much more interesting projects over here than maintaining this legacy code. It's already running.
You've been really quick at generating something to create this brown stuff. Maybe you could quickly develop something to take it away.
Okay.
Yeah, and
So, this use of this bind variables, it's a big deal, isn't it? It's got me up over into the 20,000 plus transactions a second, and the response time keeps getting better. Now, I believe I heard something about bind variables and security. I think the DBA was reading about that. I looked over your shoulder the other day and saw something.
Yeah, I was doing some more Google searching, which is what I do as my full-time job as DBA, clearly. And I found this website called, is it Ask Don? Ask Tom. It's... Don't make this stuff up.
So what I think you were going to say is that it was telling you that if you have applications that include literals in there, you certainly have an exposure to SQL injection, which means you have a potential very serious security problem on your system. So, and a good way as a DBA to get the developers to actually fix a literal SQL problem is to start talking about security. Isn't it, Tom?
I've heard that argument once. I can't remember where.
Okay. Well, it's great that we've had all this handsome debate about security and fixing code, but the target, we've just got more marketing campaigns, and it looks like
we've already reached your 20,000 if you wanted.
Yeah, but that's got to good enough yesterday. Good enough tomorrow is not that number. We need to get to 30K because we're going to run extra marketing programs at Thanksgiving. And we're anticipating to be a hit on the website. Any more ideas?
Well, yes. If we look at the system now, we have quite a bit of soft parsing going on. And while soft parsing sounds like something that isn't quite so bad, it's not as good as it can get. What we want to see is you get to an optimal parsing and a minimal level of parsing, which you can do by using the bind variables in combination with a dedicated connection for the processes. So if you would make one more minor change to your code.
You see, to get to a better connection pool, we actually ported the entire thing to Java. So we're using the Java JDBC connection pool, and I use Google too. And I found out that there is a statement caching feature, which if I enable that, right, so sometimes Google can be good. And so enable that, and instead of parsing once per execution, when my developers close the cursor, it doesn't really close it. It keeps them open. So we'll try that out.
Okay, and as if by magic, we now see.
This is a very agile developer on the end, if you hadn't noticed. You'll notice we've now got well up to my target. We're exceeding 30,000 transactions a second. The response time is rock solid. Okay, I now feel like we all might have jobs by Thanksgiving and afterwards. Not a bad thing, really. Just by the way, somebody structured the code and sent the SQL to the database. We came up from 300 or 400 transactions a second, we're over 30,000. Okay? Hope this is useful to you.
And if we look at how this is compared to how we started, now we're pretty much at maybe a 7-to-1 user to sys. So now all of the resources on this box are going to doing useful work rather than just busy work in the operating system. At the top right, in the low profile, we're doing over 100,000 SQL executions per second, and almost no parsing, almost no logons. So it's spending all its time doing the good stuff that the business needs it to do.
Now, we presented this slide, well, I presented the derivations of this next graph that's coming up. Probably nearly 20 years ago at the same conference. And usually, every time I presented it, I would see people running to their notebooks. Well, probably now they just take a picture. But the point is, as we said at the beginning, it's continual education. A lot of the people who write apps are kids straight out of school. Nothing wrong with being straight out of school, we all did it once. But they need to be given a framework and some ground rules as to how to write their applications. We know of certain companies that did this with their new graduate intake at boot camp. And the year that they forgot to teach it, it was a matter of weeks before they had serialization in the shared pool because somebody was parsing literals. Okay? This is to be brainwashed as soon as the programmer joins your company. We can't emphasize this enough.
We still see it week in, week out with very large professional IT organizations. It's not a fixed problem.
Okay. And you'll notice the correlation between, or the inverse correlation between transaction rate and response time. Okay. Comes back to what we did yesterday. You've got back, you're missing your response time targets, you're probably doing something very fundamentally wrong. Fix that first. Okay. So that's in terms of telling the developers what to do. The next issue we'd really like to deal about is things that developers do wrong. Okay, or DBAs do wrong, all sorts of people do wrong, that make code and systems literally come to their knees through either coding errors or coding poor assumptions. So, you notice we just had a big performance meltdown just take place on our system. I'm really a bit confused as to what happened there. Has there been any changes on the system, anybody?
Not that I know.
Not that I know.
So what happened?
Isn't that always the case?
A little bit more big brown stuff.
So, Brown is back. But I don't see any of the logons, it's not very high, and the parse count's not very high. Perhaps the real world team
So
give us
what's the scenario here? What's the context in which we're
Well, there could have been a small, tiny change, but it would only make things go faster. Because we tested it. we found a setting, right? A magic setting. And so we sort of slipped in with a database trigger thingy. So,
And might this thing that was slipped in be causing these things called failed parses that we suddenly see?
I didn't in test. We tested in 10.2. I know you're in 11.2, so if it works there, it must work better there.
All right, team. Tell me what's going on.
Okay, well, we're seeing a lot of time spent in library cache, back into the library cache. So, if we look up at our load profile again, one thing that we see up there is that although there's not a lot of soft parsers, there's some hard parsers, but we actually now have failed parsers in the system. So we have an application that has parsers that are failing in it. That's SQL that isn't SQL, is it, in the application? Would you like us to find it for you?
Yes, please.
Okay, so, well, we can use EM to help us do that. We can see the sessions that are getting these problems, and then we'll take a look at one of those sessions. So, failed parsers are actually can be tricky to identify. But what we're going to do now is to drill into one of the sessions and actually enable SQL trace for it, because one place that parse failures always go is into a SQL trace file. So, have we drilled into that session? Yeah.
It's running at enterprise manager speed.
Okay, so when we're looking at the session, there's actually a button up on the top right that allows us to enable SQL trace for the session. And those of you, any other Brits out there? Show of hands? So Blue Peter moment probably might mean something to them, but not to anybody else. But here's what we created earlier, right? So if we look at the trace file that's been produced from that, so the trace file gives us a log of everything that the application did. So if we look at, in this case, it's coming up right at the top, because when we enabled trace, happened to be just before we executed this failed parse. Right.
That's
So
our
it looks
performance.
like your application is trying to set an underscore parameter that no longer works with this release.
But it makes things faster. It did in our test.
Right.
So, hang on, I'm a little bit, we've got something we just put in to make something go faster, it's now making us go slower. And it's a piece of code that we've introduced that isn't running. And we managed to take the performance back to where we were before we even started. Tell me what's going on there, Graham. I'm confused.
Well, and it also is a little interesting because you say that this went faster in test. Obviously, you weren't testing it in the same environment that this is running because it certainly doesn't go faster now.
We only have 10 too. Right? This guy, he wouldn't upgrade it for us yet.
When you only had 14 rows in your M table.
You're supposed to. Scott King played Ford.
Okay, so you can see the impact of sending SQL that isn't SQL. Now, the whole thing to me is we're setting a hack parameter to probably fix something else because they're not getting the right plans. How many people have got per page triggers or logon triggers or per screen triggers, firing off, setting off underscore parameters? Setting parameters that might not work in the next release. Okay? You can just see the impact of continually sending the same SQL statement that doesn't work, what it will do to the shared pool. We brought the system to a halt by sending bad SQL to the database.
And that was just one bad SQL statement. So we know that there's about 10 SQL statements executed per transaction. You just made one of those a failed parse, and you saw what effect it had on the throughput of the system. So just one statement can destroy an entire system.
So clever programmers who want to figure out which release they're working by selecting from a table that might not exist in V2 of a release of an application. What's that going to do, Graham?
I have seen that bring systems down. Yeah.
Okay, so failed parses. Now, myself, Graham, and Tom discussed this at length about 2 years ago. Tom, how many times have you seen failed parses in your career since we brought it up to you?
Well, we were coming up with this idea of what should we present, and Graham said, failed parses. And I said, that's silly. I've never seen that. I've never heard of that. Like, who would do this? And then after he explained this, not once, not twice, but 3 times within the next 2 weeks, the problem that came across my desk was failed parses. It looked like a hard parse problem. It smells like a hard parse problem, but you can't see any duplicate SQL in the shared pool. So it's not a hard parse problem. Ask them for the parse failures. And I wrote back to the first person and said, do you realize that 6 out of 10 SQL statements you send to the database are not SQL? I'm like, oh. And they went back. They changed that, and boom, smooth sailing. And then, it happens to the best of programmers, it happens to the worst of programmers. It's a programmer being a little bit too smart, as Andrew said, to figure out what version of the application I'm in. I'm going to try to run a piece of code dynamically that only exists in the latest release. And I'll just have a when others and null after it. If it works, then I know that I'm in version 14. If it doesn't, then I know I'm not in version 14. So rather than programming to fail, program to succeed. Just query the data dictionary or something like that to see if the code exists. But a lot of developers will code to fail on purpose. And if they ever do that, just don't smack them, I guess. I want to say smack them. Never program to fail. If you're programming expecting an error in return and that means something to you, you have done something wrong.
Okay, and the other thing is just we summarize on this because we think it's actually going undetected a lot more than we think. We're seeing it, we see it about every other month. It gets to us, but there's probably a lot more going on than we think. Just look for the presence in the wait events for SQL name, break reset to client. Okay? It doesn't need to be a dominant wait event. need to be a large amount of time. Just look for the presence of it. This is Oracle returning an error code and resetting the stack. Okay? That means that somebody is getting error codes in their program. You see this happening a lot. It doesn't have to be a large percentage of the time. It just means somebody is getting error codes. If somebody's getting error codes, it's a fair chance, and you don't know about it through the application stack. People are either ignoring the error codes, or they're, Thomas said, coded looking for an error code. It's a sign of things going on. And particularly for failed parsers, you can see what it did to the system. Okay, so this is pretty important stuff, and we're going to talk about, we'll move on to the next thing that we see with the connection pools. How many people in the audience have a connection pool of sorts within their systems? They run a multi-tier architecture, very often web-facing, into an application tier, to a database. So they run a connection pool because you've got the outside world, which is potentially infinite. You've got a finite number of application servers, and you've got one database server at the bottom. There needs to be a concentration method. Well, the connection pool is subject to a lot of developer abuse. And one of the biggest areas we face is in dealing with errors, okay, and exception handling. How many people test for success when they test their applications? How many people test for failure on a regular basis in a rush? Not a lot. Okay? But how many programmers are perfect in their cleanup once they've thrown an error? How many people clean everything up? How many Java developers say, it's not my problem, I let the garbage collector do that? Who remembers being a C programmer and having to go back and balance those malloc and free calls? Okay? Maybe not going on so much. But of course, we're taking out database resources. Are we giving them back when we throw an exception? The first one we like to look at is cursors. You go through and invoke your method and you open a cursor, you throw an exception, perhaps you jump out of that code. Did you remember to close it? Okay. Did we really remember to close that cursor? We've coded up an application here to deliberately leak a few cursors, and you'll notice it's approaching max cursors. It's very quickly approaching the magic number of 300. We've got an error code. How many people have seen this error code in their life? The DBA has.
What do you do, DBA, when this happens?
Well, clearly clearly I can't use a microphone. Clearly the value for open cursors in the database is way too small. So when that happens, I increased it to 1,000. And then it happened again, so I increased it to 5,000.
And it just happened again.
And let me guess, each time you increased it, it took longer for it to fail next time?
Yeah, so it got better.
So, do you realize what that number means? I mean, open cursors, there is a per session limit. So setting it to 5,000 means that a single session, a single application, can concurrently have 5,000 cursors open. How good are your developers, Mr. Dev Manager? Do you think they can handle 5,000 concurrent cursors?
They're really smart.
So it's like 7 or 8, isn't it, that you can handle concurrent?
5,000 seems large.
Right. So when we see customers who've got open cursors set to 2,000, 5,000, all that they're doing by having the DBA set those values is they're hiding application problems. And typically, they're hiding cursor leaks in the application. So what you need to do is to identify the cursor leaks, and then you can log those as bugs against the application. Okay, so here we're in Enterprise Manager, and if we try to look at one of our sessions again, it'll come back a little faster. Right, so we've got our session here. One of the tabs along the top of this screen allows us to look at the open cursors for this section. And we can see, we know open cursors is set on the system to 300. If you look at the right-hand side there, then that top cursor has something over 80 copies of the same SQL statement. And that's because the application has continually leaked that cursor. So it's had the cursor open, it's taken an exception, it's dropped back outside of that code. Next time through, it's just created another copy of the cursor. Database doesn't know that it had finished using the previous one, so it doesn't get cleaned up. Right? So we just keep using more and more copies of the same cursor. So if you're at TBA and you get that error saying that you're out of open cursors, go and take a look at VDOR open cursors, use the EM screen, identify the SQL statements that have multiple copies. Those are the cursors that are being leaked.
It's okay, because he found 5,000. That gets us to Saturday, and we bounce. Right? The cursors go away, we start all over again.
Until you get to Black Friday, when maybe it gets you to
10,000.
Just another.
Let's go 10,000.
1 million.
You can see very quickly a programming error can get to a simple thing like a cursor. Now that's a relatively innocuous loss to the system. You've just leaked shared pool memory, and eventually the program fails. That's a kind of a low hurt in terms of leak. But there's other types of leaks that take place. And one of those, if you can leak a cursor, perhaps you can leak a connection out of the connection pool. In the previous case, we leaked a cursor such that it was programmatically unreachable and unre-executable or even closable. What happens if you take a connection out of the pool and don't give it back? Okay, so are we leaking? Are we start leaking?
We're going to start with stable system.
So we'll stop leaking sessions. Okay, so imagine in fact if you start having a connection pool and every time a program throws an error, you lose one connection to the database. Your size of your pool reduces by 1. The connection still is maintained, it doesn't go away, it's still sitting there. How many people say they see lots of idle connections to their database? How many people have written killer scripts to clean all this stuff up? I'm saying.
Regular bouncers at the app servers, anyone?
Bounce the app servers to clean all this stuff up. Quite interesting. Wonder why you wrote those. Probably you were experiencing what we're seeing here. Now we started off with a very small connection pool, which was a right-sized connection pool for the performance of the system, and we're going to talk more about that tomorrow. But today, we started off with 96 connections, and you can see we're leaking connections to the database. So the performance is dropping because there's less processes to drive it through. And eventually, you'll leak all the connections to the database. And somebody will say, well, we better start with a lot more connections in the database. How many people have got processes set in the thousands? And that keeps the system running for longer, doesn't it? But you see the memory go up, the number of active or inactive connections going on, and who's configured either their middleware or written killer scripts to make these guys go away because you haven't done anything for an hour? Or rebounce the app servers every hour on the hour, or every half hour a day. You can see we drove the transaction rate just by leaking the sessions. Okay? We drove it down to nothing. Okay? So these are examples of a programmer leaking a database structure, a cursor and a connection handle out of the session pool. It becomes programmatically unreachable, but it's still taking out state in the database. You never gave it back. And when we were all C programmers, we all understood about malloc and freeze, and we forgot to put the freeze in. We blew the memory quota. Again, in a language such as Java, which does garbage cleanup for you, but it doesn't do garbage cleanup for the database objects instead. Now, we're going to return back to Arnold. There's one other leak, which is even more sinister, associated with program leaking resources. What happens if that connection that you leaked was holding transaction locks open when you leaked it, and you didn't perform a rollback or a commit before you leaked it? You're going to have an idle connection holding a lock. How many people have lived that? Okay, so have we created our lock leak? Yep. Okay, so we've leaked a lock at this point. Now, we're going to see the same thing in real time, what happens when a session takes out a lock. And you can figure out what's going to performance. Now, you're going to see an increase in pink this time, rather than brown. But we're going to starting to see that wait event, NQTX, row lock contention. And it's going okay for the time being, but we know what's going to happen.
Right, and because we've leaked the session that is holding this lock, all that's going to happen over time is that more and more of the other sessions are going to end up waiting behind that lock. And once they're stuck there, they're not going to move. So we're going to see an increase in pink on this chart, and we'll see a reduction in the throughput of the system as more and more of our sessions are just sat there waiting for this lock that they're never going to get because the session that holds it has been leaked. Right,
So, what would you recommend, Mr. DBA?
Well, kill scripts.
Kill scripts.
Yes.
All right, well, maybe not a script. Perhaps we should do a little bit more analysis. Maybe if we look into Enterprise Manager again.
Yeah, let's take a look at the sessions that we've got now that are waiting on us. If we look at one of the sessions that click on the session ID again. Look at one of the sessions that's waiting on this lock. One of the other tabs that we've got up there is blocking tree. So we can actually see that currently there's 71 sessions. We're only running 96 in total. Are waiting on this one session. Now, over on the right-hand side of the screen, there's actually a kill button there, so we can make sure that we're killing the right guy because we've looked at it in the blocking tree. Often, what we see people doing is they start off, and often they'll end up killing the sessions that have also been waiting, right? Other waiters. Well, killing didn't take any effect. Well, that's because you're not killing the right guy. You need to get to the block. So
I just kill them all around.
I think we'd like to know what the impact is if we took the right guy out.
Yeah.
Okay, let's look at the system. It was pretty pinked out.
See, that's fixed though.
Now, this might all sound a little bit simplistic. We killed the lock holder, we'd all been to Oracle school, but there's a bit more sinister stuff going on. The fact that you're leaking locks, you're leaking sessions, you're randomly killing guys. That guy we know, did the end user think he'd committed transactions but hadn't? Okay? When you leak these sort of things, if you leak the session, do we know it was committed? If you perhaps don't leak the session, but you leak the logs, when do you know it's going to commit and roll back? This gets you into all sorts of data integrity checks problems. This becomes a real issue. And I think Graham and I, going through a lot of these issues, we can tell within 5 minutes of looking at a system what the issues are. Pretty quickly, actually.
Yeah. Open cursors set high, processors set high, are both real telltales. If you're looking at the system, if we see the SQLnet break reset, starts alarm bells ringing, because it means there's failures going on there in the system.
So you see, session leaking, it's a big deal. Okay, it really contributes to not only lack of performance, but just reliability. And it's usually in the application code, and it's usually associated with an exception that hasn't been tested. If you do it with normal code that's working correctly, and you didn't find it in testing, perhaps it's time to start looking at these values. And I think, Tom, you had a nice solution for when testing with these things.
Set your connection pool to 1. It's going to run slow, maybe, but who cares? If it can't run for 5 hours with 1 connection in your pool, then you're leaking that connection, obviously. Right? So just run with 1. And then try open cursors at maybe, I don't know, 30 or 40. Because think about it. How many cursors can your developer simultaneously have open and still know what the heck they're doing? For me, it's probably less than 30 or 40. Right? Because most developers are really, really quick to close those cursors. So why would they need more than a handful? Right? So in the test environment, go with 1 connection in the pool. And if that app server gets stuck, you have a bug. You can't go production. You're done. Go back and fix it. Right? It could be that simple.
Excellent. Yeah, and that really, that covers a lot of sessions and cursors. Lot leaking, just to recover that, we're not only talking about database hangs, and of course, my man in the funny hat will be getting the abuse. Well, the database is all hung up in logs. It must be the database fault. Well, when they're transactional logs caused by the application, it can only be the application. Did you test for it? That's the important part of the thing. And the thing that really concerns us, most of all, is the fact that we don't know where the state was when you leaked the session or the transaction. Have we got logical corruptions inside the database? Is there incorrect data, partially committed transactions? We don't know. It becomes an important part of the game. So the last stuff, I think, just to tidy up, really core application coding is something that needs to be educated in. It really needs to be education. Learning about cursor management, logons, hard, soft, and parsing once. Is there SQL statements that are being tested to fail? Then there's the developer bugs, usually associated with exception handling. And if your test process doesn't include throwing exceptions, maybe it's time to embed it. Because rolling it out at some of these big scale, we know what the impact can be. We've just shown you. And there's plenty of telltale signs when we go onto a site with dropshoes. It's usually processes set massive, open cursors set massive. Quite often, cursor sharing. Perhaps Greg and Tom would like to talk a little bit about cursor sharing.
No, we wouldn't.
No, we wouldn't.
The evil parameter. Cursor sharing force, cursor sharing similar, and the only correct setting, which is cursor sharing exact. Forget about cursor sharing similar. It's going away. Probably should have gone away, but it won't be around anymore. It's deprecated sort of already. So just cursor sharing force is a way to auto-bind your SQL. Select star from M where M no equals 1, 2, 3, 4. It'll rip the 1, 2, 3, 4 out and replace it with a bind. It turns a hard parse problem into a soft parse problem, which sounds like it fixed the problem, but soft parsing is still a problem. It will not decrease parse count at all, right? It will simply take you from losing 90% to only losing 30% of your possible gain, if you will. So it does a little bit, but it doesn't do it all. And it does nothing for the security-related SQL injection issues. If you use bind variables, you cannot be SQL injected. If you use binds, no SQL injection, not possible. if you're using literals that you put into the SQL statement, you are subject to SQL injection, even with this cursor sharing, because the binding happens after the SQL's already been injected. So it can modestly correct some performance issues, but it's not going to fix the security issues. And then there's a problem sometimes of the scope problem, right? So you like to solve problems.
Right, yeah. If you have one SQL statement or one set of SQL statements in your application that are using literals, and that's causing your shared pool to blow out. We see people changing cursor sharing equals false to fix one small part of the application. Now, when you make an init.oro parameter change, how many SQL statements in your application is that going to affect? All of them, right? So you're trying to fix one SQL statement, and you're doing it by changing something that potentially affects all of your SQL statement. That's what I refer to as a scope mismatch. So you want to have the scope of the solution as close as possible to the scope of the problem. Here you had a one SQL statement problem, and you fixed it with a database-wide solution. It's not a good combination.
And on that, I'd like to thank you all for coming.